Good day, everyone. Good day, my followers, and good day, my viewers. So, today I'll be taking you physics, and today's topic is dimension. So, now this is a past question for Unidel post EME last year. So, I'm going to break it down for you to understand. Okay, so here goes the question. Take note, this question 9 of that post EME question. It says, if this symbol here, if this symbol is the momentum of an object, then the expression phi square over m has the same unit as A. Acceleration, B. Energy, C. Force, D. Impulse, E. Power. So let's solve. Solution. Okay, now take note of that symbol that I was given. This particular symbol says what? Momentum. So let's go. Momentum. So this symbol is momentum. And what is momentum normally? Momentum is mass times velocity. Okay, so mass times velocity. Now, since we're talking, since the topic is basically dimension, there are things that we need to know. Okay, so first of all, if you're talking about dimension, there are three basic quantities that has this dimension that we use in every other aspect of what any other quantity you're going to use to solve it. Okay, so mass, the dimension of mass is m. You take the first letter. The dimension of length is L. You take the first letter. The dimension of time is T. You take the first letter, make it to be what? Capital T. But apart from that, length also has its own other what? Things they use to express what? Length. You can use displacement. Displacement is still what? Length. Since you're talking about dimension, and dimension of displacement is still what? L. We also have distance. Distance is also what? L. We also have height. Height is also what? L. And the last one, we have breadth. Breadth is also L. All are related to what? Length. Okay? Now, let's go back to the question. This is mass and this is what? Velocity. Now, we all know that mass times velocity, which is mass, times, we all know that velocity is given as what? Displacement over time. Okay? Displacement over time. So what I'm going to do here, what is the dimension for mass? Trace capital M. What is the dimension for displacement? Trace displacement, I say it's same as length. Dimension is what? L. Okay? What is dimension for time? Capital T. So once you multiply, M times L, ML over T. So divide by T. So this is the dimension for momentum. Now you go back to the question. The question says what? Then the expression, it says, so it means this expression, this symbol here, which is square over m, meaning I'm going to do the square of this over m. So it means what? Over m. This m here is mass. So now, here is going to be what? M L over T, brackets, close your bracket, put the square, over, what is the dimension of mass? Trace m. Okay, now since it says square, so let's square it. ML over T square. What are you going to have there? You're going to have m square L square over T square, okay, over this M that is here. Okay, so now in mathematics you can drop this one down, okay, to make your what, your simplification more what, easier. You can drop this one down. Once you drop it down, you're going to have M L square over ML square over M with your T square. So this one can cancel. There's a square here. This one can cancel this one. So what is left is ML square over T square, which is giving us ML square. Push this one up, you have T raised to the power of minus 2. Now, after solving it, they are asking you from this, which one have the same unit? So without wasting time, if you know it's not possible, acceleration is not possible. When you try force, it's not possible. When you try energy, it's not possible. When you try impulse, it's not possible. So the closest answer to this is power. The closest answer to that is power. Is power. So now let's prove it. So we're going to prove it now. So let me prove it. So let's start with acceleration. So meaning anything we're going to solve now, anything we're going to solve, if it's related to this, we'll pick our answer. Okay, so let's start with acceleration first with A. For option A, option A says acceleration. So let's start. What is acceleration? Velocity over time. Okay? Velocity over time. So what is velocity? We already saw velocity here. So velocity was what? L over T. So let's go. L over T over what is time? T. So L over, draw this my T down. T times T. So we're going to have what? L over T square, giving us L T raised to the power of minus 2. So meaning for this option A is not the same thing as this. So we're going to kick it out. Now let's go to option B. Option B is energy. Option B is energy. So let's do one for energy. Option B, energy. We will know that energy is the same as work. Energy is ability to do work, and work is force times distance. So energy is almost equivalent to what? To work, because it has the same SI unit as what? Work. Energy, SI unit of energy is joules, and the SI unit of work is also what? Joules. So definitely they are using almost the same formula. Okay, so let's move on. Now energy is already what? Force. Since it's same thing as work, force times distance. What is my force? My force is mass times acceleration. My force is mass times acceleration. Times my distance. Okay, so now what is my mass? Mass is m. What's my acceleration? We have solved acceleration to be here. Lt minus 2. And what's my distance? We have solved our distance to be what? Our distance, trace your distance here. Our distance is what? L. Put your L here. So multiply all through. So this is what I'm going to have. M L times L, L squared, T raised to the power of minus 2. Now, if you trace very well, this thing here is the same thing as this. Take our, remember we are what? We are showing that this momentum square over M is the same as what unit in the option or what quantity in the option they're asking you. So now, after solving from here to here, this thing here, this particular dimension that we have gotten here is the same as this particular dimension. So definitely our answer is option B. So option B is our answer. So this is how you solve such particular what question, relating it irrespective of how the question is being asked. So far you know the dimension of each of the required what quantity. So thank you very much for watching. I still remain teacher Patrick. Please like, share and comment. See you next time again. Bye bye.